All right, boys and girls, welcome back to the drive-through. What am I shouting out today? Shout out to the spring. It's coming. 70-degree weather. I'm not all about, I don't like global warming, but I guess I'll enjoy it while we have time. All right, here we go. Just trying to help you guys with what I think might have been the hardest parts of this worksheet. So hopefully you understand that before the tournament plays any games, there are 64 teams. And then after the first round, there are 32 teams, and then 16 teams, and then 8, and then 4, and then 2. And after 6 rounds, a champion is declared, okay? Well, this doesn't make sense in the basketball analogy, but that would be the next math number, okay? That's what the pattern suggests. So, when we graph these, what did I do? I just had 1, 2, 3, 4, 5, 6, 7 over here. And then you could have gone a lot of different ways when you graph these. If you put 10 there, you didn't get high enough. So I put 15 here. Skipped 1 and put 30. Skipped 1 and put 45. And then skipped 1 and put 60. Okay, you did not have to do it that way. But that works for me. This is a 0. So let's talk real quick about something that we do really understand. Okay? You remember this is an equation of a line? What's the y-intercept in this equation? It's 10. Very good. Okay? We can treat the y-intercept like a lot of different things. You can think of it as the starting point. Okay? You can also think about it as where does the line cross the y-axis? Or you can think about it as what value do we get when we put in 0 for x? All of those three things are the y-intercept. Okay? So, if you think about this one that we're doing, the y-intercept, it still works that way. If you put in 0 for x, you get 64 for y. It's the y-intercept, okay? 1 comma 32. 32 would be about here. It's halfway up. Every time I go up, I go half as far up as I did the last time. If I put in a 2, I get a 16. If I put in a 3, I get an 8. Put in a 4, I get a 4. Put in a 5, I get a 2. 6 is 1. 7 is a half. And now, so, we've never worked with this curve before. You've worked with curves before. You've worked with curves that did this. Okay? That was x squared. You work with curves that did that. That was x cubed. Or that would be negative x cubed, sorry. But now what we're going to be working with are called exponential curves. Remember the rabbit situation we talked about last week? This is the opposite of the rabbit situation. If you look at it the other way as it grew, if we started out with 2 rabbits, and let's say, I don't know this, let's just say rabbits can reproduce every month, okay? So, after 0 months, we had 2 rabbits. And let's just say, and I don't think this is how it works with rabbits, but let's just say, every time they had 2 rabbit babies, 2 bunnies, and they were boys and girls, okay? So after 1 month, let's say we had a mama rabbit and a daddy rabbit, and they had 2 so now there's 4. Well, forget about the fact that there might be bad DNA here because they're going to start having incestual kids. But let's say that now this is 2 boys and 2 girls. And they each reproduced to make 2 boys and 2 girls. Well, now we'd have 8 rabbits after 2 months. Does that make sense? And then after 3 months, we'd have 16 rabbits. And after 4 months, we'd have 32 rabbits. And then here's where it starts to grow really fast. Okay? And just after 7 months, you would have 356 rabbits. Now, I will tell you, for those of you out there that like animals but aren't as far left as like PETA, that's probably where I am. I don't like PETA all that much, to be honest. But I also don't think that cows should stand in a factory and do nothing for their entire life until they get slaughtered. So somewhere in between there is probably where I fall, in between PETA and treating cows bad. There are a lot of like farmers out there that think we should eat more rabbit because it tastes good and they're easy to take care of and they reproduce really fast. Okay? So there are people out there that think that. And maybe that's probably a good solution, I think. Because look, in just 7 months, if you were a homesteader and you got yourself a couple rabbits and you don't mind eating inbred rabbits, you would have 356 rabbits in 7 months. That'd be awesome. You could eat for the whole year. Okay? It'd just be a lot of rabbits too. But maybe you could trade 300 of your rabbits to your neighbor who grows cows, and now you got 56 rabbits and a cow. Now you're talking. Okay? So anyway, where we're really going with this stuff, why it actually I'm excited, because eventually we're going to talk about graphs that look like that, and those would be growth graphs. This is what you want your money to look like in life. This is what happens when you invest it. It grows slow, it grows slow, it grows slow. Now it starts to grow a little faster, and then you get enough money that you don't even need to work anymore. Your money is what makes you your money. That's how rich people do it, just so you know. But it takes time and it takes equity, which is you got to save it. And this is called decay. And that's what credit card debt looks like. It's no big deal, it's no big deal, it's no big deal. We're just losing a little percentage here and there. It's no big deal. Okay, it's starting to affect me. Okay, now I can't pay for my house anymore and I foreclose it. That's literally how it works. So there's growth and there's decay, and they're both exponential functions. Okay? That's why I'm excited to teach this to you guys. So now let's help you out with the equation part. That was probably the hardest part of the front page, number 7. Okay? So remember that this is x and this is y, or this is f of x. And in number 7, it says create an equation that represents this scenario. What if instead of writing it like this, I told you guys to write it like this, 64 divided by 1. Anyone know what this is? 64 divided by 2. Now be careful, because there's 2 ways we could say this. There's 2 patterns going on here. Anyone know what this is? It's 64 divided by, oh, why did I put 63? Because I am dyslexic. 64 divided by 4. Now it looks like 69 divided by 4, 64. It's divided by 4. So now hopefully you see the pattern. What's the next one? 64 divided by 8. What's this one? 64 divided by 16. What's this one? 64 divided by 32. 64 divided by 64. 64 divided by 128. Aha! That might make it a little easier to see what this equation is. What's happening to the top of our fraction? Nothing. So this becomes the hard part. Anyone know what goes on the bottom? Here's what's hard. What is this number here? It's 2 to the first. Very good, Alex. What's this one? 2 to the second. This one. 2 to the third. This one. You see it? So it's 64 divided by 2 to the x. Now wait just a second. Actually, write that down for number 7. Okay? Let me talk to you about some things that might confuse you. Do you remember how you hated this in algebra? What's 2 to the 0 power? It's 1. You hated that. Now look at this. This is 64 divided by 2 to the 0. That's why it has to be that way, or else it doesn't work. Okay? Now I want to go from what this is to how we're going to write it, because we are not going to write it like that. We're going to write it as 64 times 1/2 to the x. That means the same thing, because dividing by 2 is the same thing as multiplying by 1/2. So now, maybe you notice that this is what it looks like on the back of your sheet. And this is what's totally cool. If we can just understand this base equation right here, and always remember this little March Madness paper that we had, excuse me. This number right here is how many things you want to start with. Okay? So in our rabbit example, that was 2. We started with 2 rabbits. This number right here is what happens every time something happens. And in our scenario, it was every time another tournament round was played. In the rabbit scenario, it was every time a gestation period was completed. Okay? And then this always just stays the same. So every time another tournament round was completed, we had half as many tournaments. Okay? So let's go ahead to the back now. And we're just going to do number 1. Now I want you to know that number 1 really says y equals 1 times 2 to the x. Just keep that in mind as we go forward. All right? I'm not concerned about the graphs. I hope all you did for the graphs is pop them into your graphing calculator and then use the table. Okay? But if you put in a 0 for x, you get 2 to the 0 power. So what is our y-intercept? It's 0, 1. Because 2 to the 0 power is 1. Now you probably just wrote a 1 down for that, which is okay, that's normal. But write it as a point so you understand. Oh, it's when x equals 0, what is y? Okay? And then this one is getting bigger. As you put in a 1, you get a 2. Put in a 2, you get a 4. Put in a 3, you get an 8. Put in a 4, you get a 16. And it kind of looks like a parabola. But it's not. If you put in a -1, it's a half. So this is what you get. Okay? So what is our base in this problem? It is 2. And I forgot to copy what's below that. But does this appear to be growth or decay to you? Well, hey, remember, we struggled with the science part on the ACT. That's reading graphs. How do we really usually interpret time on a graph? Is it left to right or right to left? It's left to right, always, on a timeline. Well, if we had a timeline and this blue thing represented your money, would you be happy or sad? You'd be really happy. So that is growth. Okay? That's a growth. So now let's just do one more. Now hopefully now we can, yes, Katie. The base is this number, and it represents what's happening each stop along the way. So this would be like our bunny problem. The difference is somehow we only started out with one bunny. And I don't know how that works, but I'm no scientist. Okay? Okay, so now, Katie, what's the base in this one? It is 1/3. And so now I think I know that every time along the way, we're going to decrease our output by 1/3, which means this one, without graphing anything, that's going to be decay for sure. Katie, do you know what our y-intercept is on this one? Did you get this one done? Okay, so how do you think you find the y-intercept if you didn't have a graphing calculator? It is the number outside. That is the y-intercept, which is why we want to write it that way. Okay? And now this would just be the equation. So I know that at 0 you're going to have 3, and I know that this is decay. So at -1 you probably have something really big. Let's see, that's 3 times 3. -1 would be 9. And so 1 is 1. This is a third. That's about all the points I can get on there. Sorry. I'm writing in my own shadow. This is hard. I got to turn myself into a lefty real quick. Whoa. Did you guys hear that? Okay. Got it? Does that help? Okay. I'll check this for a grade tomorrow. Boom!